Hello everyone. In this video, we are going to talk about the affine subspace and the shift plane. So in the class, we have been talking about the idea of span S. And now we are going to give you an idea is saying that any set that is of the form of span S, then it is called a subspace, 子空间. So for example, if there is a set, it's called S, and this set contains only one vector, 1 minus 1, then you can consider span S, then it is the straight line on this blue area. You have the 0 vector, which is 0 times this vector. You also have 1 minus 1. You have 2 minus 2, 3 minus 2, 3 minus 3, and so all the lines, all the points on this line is the set span of S. So a set like this, we call that as a subspace. It has a feature that it is very flat, and usually it is a point, a line, or a plane. And notice that span S, no matter what the set S you are giving me, it always contains the vector 0. Because 0 is equal to 0 times your vectors plus 0 times u2 plus dot dot dot. And in the end, 0 vector is always a linear combination of any set. So whichever S you give me, I always have 0 in the set. So this means that a subspace is a straight line passing through the origin. It could be other direction, but it always passes through the origin. Now, how about this kind of structure? Well, this kind of structure is also very common, right? You can see, for example, x plus y equal to 1. It has this kind of structure. And this kind of structure, we call that as affine subspace. And basically the idea is, it is a plane, but it is shifted, 平移过的. So I have a plane here, and then you shifted it. So this kind of structure, we call that as an affine subspace, and the intuition is shifted plane. Now the question is, how are we going to define such a structure? Before talking about that, we're going to talk about a new idea. We know how to do the addition of two numbers. But now if I give you a set, maybe the real numbers, or the set 1, 3, 4, okay, and I give you another element, maybe just a number, then how are we going to add that? Okay, so we're going to define that if I have a number or an element and I have a set, it has a lot of elements inside, then when you have k plus s, it is defined as the set of everything looks like a k plus s, such that s is an element of this set S. It will be easier to look at an example here. I have a set which is all the multiple of 3, 3的倍数, which contains 0, 3, 6, and minus 3, minus 6, a lot of numbers. So I have a set, I have a number k, and when I say k plus s, then it means that 1 plus minus 6, 1 plus minus 3, 1 plus 0, and so on. So it is the set that looks like this. Another example, because the span is also a set, right? So in the previous example, the span is a set that composes of all the vectors on the straight line. The other way to say that is t times the vector, where t can be anything. So if I say a vector plus the span, which means that the vector plus whatever this vector in the span. So in this case, I have the vector plus a multiple of this direction. And you know this is the formula of a straight line. You have to go to this 1, 0 vector, and then you go on this direction, 1 minus 1. As a consequence, this set composed of all the vectors on this blue straight line. Okay, having enough background about the affine subspace and the idea of a vector plus the span, now we are going to give you some exercise. Similar to what we have done in class, if I have a vector u, another vector u1 and u2, and I say the set S is equal to u1 and u2, then I can consider its span, and I want to consider the affine subspace P plus span S. This is the subspace and shifted subspace. I also have another vector B. A natural question is whether this vector B is in the affine subspace. So I encourage you to pause the video and think about this question. Similarly, we have another problem. It is the same setting. You have the same U1 and same U2 and the same P. So this is the same affine subspace. Now I give you another vector called B, and this B is it in the affine subspace. Again, I encourage you to pause the video for a while and really calculate the answer and figure it out. Once you have the answer, you can check out the article and see whether your answer is correct or not. The links of the article is included in the information area of this video. Finally, you have already gone through all the video up to here, and I want you to sit down and think about what you have learned about this video. When you do this, you will think about all the contents, and maybe we have been gone through subspace, affine subspace, and so on, how to determine if a point is in it, and what is the meaning of an element plus a set. So pause for a while and think about what I have learned in this video. This will benefit your learning overall.